Very good morning and good morning to online students too. Please switch on your cameras. The first thought is failure is an event, not a person. Your attempts may fail, but as a person you will not fail. First attempt, second attempt, third attempt, no problems, no? This is for all other batches. This batch is the final list. Okay. So whatever I say, it's for other batches. And I say the same in every batch. Please write the second one. Second one is good for essay writing. Good for social issues related topics. We are humans until race disconnected us, religion separated us, politics divided us, and wealth classified us. Do not worry for the results in the examination. Anxiety is the interest paid on a trouble before it is due. Worry later on when the results are not good, okay? But before that, enjoy your life. For success in general and for your examination success in particular, we don't have to be smarter than the rest, we have to be more disciplined than the rest. Average students have done wonders in this exam just by being disciplined for a few years. Merit comes later, first hard work is more important in this exam. Merit will only help you polish your results to a better rank, but before merit, you need to work hard to complete the syllabus. Fine, now pravachan is over. Let us do geography now. If you remember, we have done concept of latitude and longitude last time. Now see, in today's lecture also will not have any main topic being started. Today I'll give you something of the previous lecture and plus number of other things which are going to be the elements of my future classes. So from next lecture onward, we'll have some specific topics being covered. Now, the first subtopic would be that we'll convert in next 15 minutes each degree of latitude and longitude into linear distance. Means we'll check a degree of latitude would mean how many kilometers on this earth. And similarly, we'll do it for longitude. So please write the title. Conversion of a degree of latitude or longitude into linear distance. You know, latitudes and longitudes are angular distances. We'll convert them into linear distance. Now let's do first for latitude. The task is to convert 1 degree of latitude, means we wish to see that the degree of latitude is approximately how many kilometers on the Earth's surface. Now see, to make this conversion, I first should establish a relationship between latitudinal, the angular distance, and linear distance. So for this, let's recall what we did in the last lecture for the angle called latitude. We said latitude is the angular distance north or south of the equatorial plane of the Earth. So if my left means, this is what I said last time, if my left hand is the Earth, I repeat, if my left hand is the Earth, imagine a plane which cuts the Earth through the middle into two parts, the northern hemisphere and southern hemisphere. This plane which cuts my Earth into two halves is what we call as equatorial plane. In the last lecture, I represented the equatorial plane with my left hand. And if you recall, this point I took as the center of the Earth, and this tip of the finger as point A, which was on the Earth's surface right in the middle of the Earth. And then I took a point P and I represented it by the tip of this right hand finger. When I put P over A, there is no angular distance of P from equatorial plane. It is 0 degree. Now, how many degrees I go on the north of it or how many degrees I go on the south of it is called latitudinal distance. So let's make an angle of 90 degrees latitude and see how much is the linear distance for that. So as I make an angle of 90 degrees, you please focus on this tip of the finger which is representing point P. How much does it move on the Earth's surface? So now it is at the equatorial plane. What is the latitude of P? 0 degree. Now if I move it to make an angle of 90 degrees, now can I say, now you know this is 90 degrees north. So since I do not have the third hand, so you just imagine it here, right? So can I say the point P has moved from the equatorial plane to this 90 degrees north. So this is the linear distance on the Earth which the point P has traveled for making an angle of 90 degrees. Is it okay for everyone? Now can I say this distance or this means whatever you call it as, this distance is 1/4 of the circumference of the Earth, and circumference of the sphere is 2 pi r. So it means we get a relationship 90 degrees of latitude would equal 1/4 of the circumference, 1/4 of 2 pi r. Remember, unless until said otherwise, Earth is a spherical body. So I take 2 pi r as the circumference, where r is the radius of the Earth, pi value you know. Now since we need an approximate value, radius of the Earth you can take approximately as how much? 6,400 kilometers. Okay. So if you have understood this, please make a calculation fast. Tell me how many kilometers would be there for 1 degree of latitude. Do it offline, online students, please do it fast. Be quick in calculations. CSET is qualifying examination. I hope you remember, no? The whole exam preparation goes waste for other batches if CSET is not clear, no? Abhishek Tyagi has given the right answer. Online first student, 111 kilometers. Everyone should reach to this answer. This answer is approximately 111 kilometers. Yes, Rohan has done. And what about offline students? How many of you have got this answer? Please do it fast. You know the value of pi, you know the value of r. Get 1 degree of latitude. Aarti online needs to check the answer once again. No, Rohan Kumar says I didn't get how do we reach to 90 degrees? See, it means you do not know what we have done last time. See here, what was latitude once again for Rohan and others, those who have not understood. If my left hand is the equatorial plane, what is equatorial plane? The plane which cuts the earth through the middle. From here we measure how many degrees you are on the north or south. This is called latitude. Now if I put my right hand over the left hand and I say this is a point P, this tip of the finger represents some point P of the earth surface. If I put it on the equatorial plane, what is the latitude of this place P now? 0 degree. Now if I move it to make an angle of 90 degrees, now the hands make an angle of 90 degrees latitude. So to make this angle of 90 degrees, how much is the movement of this point P on the earth surface? It is this distance from equator to North Pole. And this distance is how much? It is 1/4 of the circumference of the earth. And circumference of the earth is 2 pi r. Okay. 1 degree of you, how many degrees you are calculating? You are supposed to calculate 1 degree of latitude, no? Read the question carefully. You are supposed to find out 1 degree, not 90 degrees. Yes, is it okay for everyone? Now, if this is okay, before we go to longitude, I'll make one small observation, though it's not very important, but you may come across this statement somewhere. So please be on the boat. We have done this calculation with Earth being a perfect spherical body. But now let's make one observation in relation to that misshapening of the Earth we had done last time. You know, at the poles, Earth is slightly flattened. Now, if I was to visualize that on my left hand, if left hand is the Earth and this is North Pole, what would flattening mean? Flattening would mean that I need to press this point of my left hand to make it slightly flattened. When I press it, can I say the skin of my left hand would get stretched? Yes, please. So if you understand that when I press my left hand's top portion here and the skin gets stretched, can I say 1 degree of latitude would be slightly more at the pole in comparison to what it is at the equator, because here the skin is getting stretched. Though it's not a very important, means it's not very significant value, but just to understand conceptually, we should write this statement. So write one observation. As Earth is slightly flattened, at the poles, put a comma, the linear distance of a degree of latitude, the linear distance of a degree of latitude, the linear distance of a degree of latitude is little longer at the pole, than at the equator. I repeat this sentence. As the Earth is slightly flattened at the poles, comma, the linear distance of a degree of latitude is little longer at the pole than at the equator. Now let's do this conversion for longitude. So write second. And now our task is to find out 1 degree of longitude would mean approximately how many kilometers on the Earth's surface. Now for this, let me make first a diagram and see what value would be important for us. Now see, I wish to find out 1 degree of longitude. So what I do is, I draw 2 meridians on the globe which are separated by 1 degree of longitude, and then see what is important for us in this. So I draw one meridian, that is line connecting North Pole with South Pole. Now let's suppose the next line I am drawing at 1 degree distance in terms of longitude. So let's say the next one is this. Now you notice that 1 degree of longitude is maximum at the equator, and as I go towards the poles it is decreasing. So this value is of importance to us, and then as I go towards the poles in both the hemispheres, this value is decreasing, and finally at the north and south pole it would be 0, because all meridians converge at the poles. So I'm interested in 1 degree of longitude, so I take different cases. Number 1, please keep writing this with me. At the North Pole and South Pole. Now can I say it's clearly visible in the diagram? That value is 0, because all meridians converge at the poles. So the longitudinal distance is 0 at the poles. A degree of longitude is 0 in terms of linear distance. Now what is the second value we are interested in? Yes please. What is the value of 1 degree of longitude at the, yes please, equator? Means we wish to find out how many kilometers these would be. Now for this distance, I need to establish a relationship between longitudinal distance and linear distance. So keep your eyes on the board and think of a spherical shape. Can I say at the equator I see a clear relationship that 360 degrees of longitude would equal the circumference of the earth? Remember, equator represents what? Circumference. And how many degrees of longitude are there at the equator? 360 degrees, no? See here, last time I was doing this. If this right hand is the Greenwich meridian, how much I can go on the east of it? 180 degrees, and I can go the same distance on the west also. So at the equator, I have a clear relationship, 360 degrees of longitude equal the circumference of the earth, that is 2 pi r, we already know this. And please see this expression. Can I say this expression is same as what we have written earlier? Earlier we said 90 degrees of latitude equal 1/4 of the circumference. And now this expression says 360 degrees of longitude is equal to 2 pi r, the circumference. It means 1 degree of longitude at the equator would be same as 1 degree of latitude was there for the whole earth in general. So when you calculate 1 degree of longitude at the equator, 1 degree of longitude would be approximately equal to again 111 kilometers, because expression is the same. Earlier we said 90 degrees of latitude is 1/4 of circumference, and now we are saying 360 degrees of longitude is equal to 2 pi r, the circumference. Yes please, is it okay? Yes please, is that fine for everyone? Now, though it is done, but let us go for one observation. I'm going to give you one more observation. We will not do it mathematically, we will just remember this third case because calculation is not important. Now see, at the equator, a degree of longitude is 111 kilometers, and as I go towards the poles, it becomes 0. It is decreasing as I go towards the poles. Please tell me, by looking or by visualizing this spherical shape, please tell me at what latitude, from 0 to 90 degrees, at what latitude a degree of longitude would be approximately, let's say, 56 kilometers, which is about half of what it is at the equator. Means where, from equator to the poles, where this 1 degree of longitude would be approximately half of what it is at the equator. Yes, I got 3 answers. Someone says Tropic of Cancer. Someone says 60 degrees. And what was the third answer? 45. So choose one out of these 3. Yes, he says 60 degrees. See, those who say 45 degrees, they need to check. Means if answer was 45, why would I ask you this question? No. Now, why the answer is not 45? I'll put it very good. I'll put it this way. In my 7th lecture, I'll be discussing these things in more detail. Now, keep your eyes on the board and think of what he's suggesting. Since my earth is spherical in shape, so it gets smaller as I go higher in latitudes. Is okay or not? See, this earth, which is lower latitude earth, is very large. But as I go higher in latitude, earth is getting smaller. Do you notice? Polar region, earth is very small, whereas here near equator or in lower latitude, earth is very large. So earth gets smaller as we go higher in latitudes. Is that fine? But let's make a finer statement out of this. What I have just said is good for a school child. But since you are more mature, I make another statement better than what I have done earlier. I say, since my earth is spherical, it gets increasingly smaller in higher latitudes. It means you need to notice that earth is getting reduced in size as I move from equator to the poles. But the rate of decrease of the earth size is gradual, is less in the lower latitudes. But earth gets smaller at a faster rate in higher latitude. If you move your eyes from 0 to say 20 degrees here, yes, earth is getting smaller, but very minutely. But when you move your eyes for the same 20 degrees here, 60 to 80 degrees, then the earth is getting smaller at a faster rate. So that is why the answer would not be at midpoint 45, it would shift to the upper side of it, right? So you just write today, because we'll be doing it in another topic more in detail. So it means you need to know that this degree of longitude would be approximately 56 kilometers at somewhere 60 degrees. Let's say somewhere here at 60 degrees north and south. Okay. So please write. Third observation. At 60 degrees north or south, at 60 degrees north and south or north or south, put a comma, a degree of longitude is about 56 kilometers. A degree of longitude is about 56 kilometers within brackets, which is approximately half of what it is at the equator, So you need to remember 3 things for this longitude. At poles it is 0, at equator it is 111 kilometers, and it becomes half of what it is at the equator at 60 degrees north or south. And this is all because the shape of the earth is such that earth is getting smaller at a faster rate as you go towards the poles. Okay, that here the reduction is very less in size when you move your eyes here, but for the same distance when you move your eyes here, the earth is getting smaller at a faster rate. Those who are still not getting, when you move your eyes here, it is like moving my arms here. Cylinder, no? Not understood. Leave it. I could not have tried better than this. So this first subtopic is over. Now there is a student asking me, sir, at which degree it gets faster rate? Very good. Sitting in your place, you can ask any question, no? Point is, at every next degree it is faster. Okay? So you need to ask me further a better question at, give me a rate, then I'll tell you at this rate it increases faster at this latitude. Remember, from lower to higher latitudes as we go further, the rate is increasing. So Earth gets increasingly smaller in higher latitudes. It's a relative sentence. So when you make a question, think of what exactly is the point, that the rate of the decrease of the Earth size is increasing from equator to the poles. Okay. Now, let us see what is the next discussion topic today. Now, I will not write the topic straight away. Let's have a brief discussion for 10 minutes or so and reach to a topic. Please don't write me on the board. We have learnt two different ways to move on the Earth's surface. One is latitudinal way, that is north-south, and the other is longitudinal, that is east-west. Is that okay for everyone? Now, we learned one term in the previous class, insolation. Insolation is incoming solar radiation. So I may use the word insolation. Sometimes I may use the term heat also, or in general sun's energy. And you know in the background from your school days as well as my second lecture that as Earth goes around the sun, because of the changing relationship of Earth and sun, it appears as if sun is also moving. And in 1 year's time, sun moves between the two tropics. And since sun moves between the two tropics, so the two tropics become the farthest limits of the vertical rays of the sun. Yes, please? It means the lower latitudes near equator or the area between two tropics throughout the year would have higher angled sun's rays. Yes, please? And as we go higher in latitudes, throughout the year, rays would be more inclined. Is that fine? Now, keep all this in mind and I make an observation. Please confirm this understanding. Can I say the primary distribution of insolation on the Earth's surface, mind the words, the primary distribution of insolation on the Earth's surface would be in terms of latitude. Major distribution of energy of the sun would be seen in terms of latitude or longitude? Latitude. Because you know sun is moving to the two tropics. So one broad understanding is as I go from equator to the poles, the insolation is decreasing. Or I say lower latitudes of the world are being heated more intensely throughout the year, and higher I go in latitudes, the heating gets diffused. So is this good for everyone? That insolation gets primarily distributed on the Earth's surface in terms of latitude. I am not saying that Earth's surface is being heated uniformly longitudinally. No, even longitudinally you may have the differentials in heating, because one longitudinal block may be water, the other block may be land. So heating would not be same. And as the classes go further, you will understand, even if two areas are having the same land surface, but still they may not be heated the same way, because one land area may have grassland, the other may have desert, or one may be forest, and within that also you may have further variations. So we are going to see in geography and ecology classes that different surfaces of the Earth would be heated differently. After a few days, I'll be giving you a term, albedo. Albedo is from Latin word albus. Albus in Latin means white, and you know white stands for reflectivity. So by albedo of a surface we would mean that out of the total incident energy, what percentage gets reflected back? It means different surfaces will absorb different amounts of sun's heat. So two surfaces may receive the same amount of sun's heat, but they are still not heated the same way because the surface is not same, because albedo is not same. This is not today's focus, but just to give you an idea, some of you may know that freshly fallen snow has an albedo of 90%. Means out of the total incident energy on the fresh snow in a high mountain, that out of the total energy which is there incident on the surface, as much as 90% gets reflected back. And that is why when you go for skiing to high mountains, especially in summer, you need a very good protection for your eyes. Because if you do not have anything to protect your eyes, a strong glare by that reflected light can damage your eyes immediately. So out of total energy, only 10% is being absorbed. And as the classes mature, you'll understand this is very important for what is today's global issue, the global warming, the climate change. Remember, in every talk about climate change, they mention about the melting of snow and ice. Now, let me give you opposite example of this albedo. Every surface has its own value, but after a few days we'll discuss it more. Now, opposite example or other extreme example is, you are in a city like Delhi in the month of June in summer, and let's say you went out for some work from your hostel room, but on the way somewhere you happen to lose your sleepers. So think of it, you have lost your sleepers somewhere. Now can I say, in the month of June, having lost your sleepers, you will jump back to your room. You can't walk back to your room. Why? Because in the urban centers like Delhi, on the road surface we have one black material, bituminous material, and that material has 10% albedo. It means on a summer day, whatever energy of the sun is falling over it, as much as 90% gets absorbed and 10% gets reflected. Then you'll have to, I hope you understand now, you'll jump like a frog, not walk like a human being, So it is almost opposite of snow. So this is the way we understand that all surfaces would have their albedos. So all this will come later. But is class agreeing with me that the primary distribution of insolation on the earth's surface is in terms of latitude? Now, if you agree with this, let's move to the next point. How much moisture, vapor, the air can hold, it depends on its temperature. The rule is, the warmer air holds more moisture. Why? Because air holds moisture in its intermolecular space. And which air would have more space? The warmer air. So moisture holding capacity of air is a function of its temperature. And the rule is, warmer air holds more moisture. It means, can I say, lower latitude atmosphere would be generally very moist. And as I go higher in latitudes, the conditions are getting colder and hence dry also. Yes, please? So it means we make another important conclusion for understanding nature, that earlier I said insolation varies primarily on the surface in terms of latitude. Can I say the moisture in the air would also vary primarily in terms of latitude? Because moisture holding capacity is a function of temperature. Is okay? Now, it means you have agreed that heat and moisture in the atmosphere vary primarily in terms of latitude. Can I say these two are the major elements of the climates of the world? Means when you think of climate, which are the two important elements which immediately come to your mind? It would be heat and moisture. Even if you ask a common person on the road, he or she will think of these two elements. They are so major elements. There are other elements also in the climate, but these are two most clearly manifesting elements. So can I now conclude the climates of the world are majorly distributed, primarily distributed in terms of latitude? Means how would I see the major climatic variations? Latitudinally or longitudinally? Latitudinally. So if climates vary primarily in terms of latitude, can I say the vegetation types of the world, the forests, the grasslands and the deserts, they would also have primarily the variations in terms of latitude? So it means climates and vegetation both vary primarily in terms of latitude. It means I have a reason to say the whole life on the earth's surface varies primarily in terms of latitude. So in just 5 minutes we understand for both subjects, the geography as well as ecology, we would have more the reasons to move on the earth's surface latitudinally in comparison to longitude. Remember, we are interested in understanding longitudinal differences also. We would like to see what is the difference between Eastern Pacific Ocean and Western Pacific Ocean in some topic. Have you seen in newspapers a very important event these days, El Nino? It is Nino, not Nino. It is pronunciation is Nino. So we will see El Nino would relate to some difference between the Eastern Pacific Ocean and Western. Even if you are moving the same latitudinal region, still there are important longitudinal differences. We will see Indian Ocean dipole when we mature with the classes, and that would be a phenomenon between Eastern Indian Ocean and Western Indian Ocean. And there would be many other such kind of interesting things which will be there in the final phase of the classes. So we are interested in East-West differences also. But when I am dealing with the primary discussions, when I am focusing the primary and the major kinds of variation, they are in terms of latitude. Is that okay for everyone? Remember, first we have to understand the major ones and then we can go for the longitudinal differences also. So if you have understood my point that most of what we need to study in ecology and geography varies primarily in terms of latitude. So it means to get prepared for the future classes, it would be good for us if we divide our Earth surface from equator to the poles in terms of latitudes. So that tomorrow in any class, if I want to talk about one particular area of the world, we should have some nomenclature for it. At the moment I mention that nomenclature, everyone in the class should understand the same region, right? So it means my topic is latitudinal division of the earth, that I have to divide my earth into different zones for starting the subject of geography as well as later ecology with the other teacher. So please write this title. Latitudinal regions, and someone may use the term instead of region, zones, or instead of region or zones you can also use the term belts. So we are not going to recognize the latitudinal regions or zones or belts of the earth. Now we'll do it with the help of a diagrammatic presentation. So make a big circle and draw on that big circle all the important parallels we did last time. Remember, we said equator, the two tropics and Arctic circle and Antarctic circle are important because they helped us understanding distribution of insolation on the earth surface. So today we'll take the same parallels to divide the whole earth surface into 6 latitudinal regions. So please make the circle to represent earth. And please draw the important parallels learned last time. 0 degree, the Tropic of Cancer, Arctic Circle, and finally North Pole. Draw the mirror images in the southern hemisphere. Sorry. We are going to divide the whole Earth surface from equator to the poles into 6 subregions. And before I start this division, let me make a caution that whatever regions we'll do on the board in the next 10-15 minutes, they are all given by the scientists of the world based on the observations of nature. By making this sentence, I'm making everyone understand that nothing is based on your discretion or my discretion. I hope you understand the point. We are in a science class. Scientists of the world have seen the nature, and on that basis, they divide the whole Earth surface into how many regions? 6 regions, okay? So it is based on reality of nature, not anything else as such. Now, the first region scientists identify is equatorial region. In total, we'll have 6 subregions, but we start with the area near equator and we call it as equatorial region. Now, let's have one further clarification. When I use the word equatorial in English, what does it mean? It means that we are talking about area near equator. When I use the term region in English language, it means it's an area with some homogeneity in it. It's an area with some identity of its own. For example, in Indian geography book, you may find somewhere one area of India being called as wheat region of India. Now, if someone says this area of India is wheat region, immediately you understand that this area has one identity in terms of predominant crop being wheat. That predominance of wheat binds it as one area, gives it one identity different from other areas. So, region means an area with a homogeneity. Now, when I say equatorial region, you immediately understand the teacher is talking about area near equator with some homogeneity. Yes, please. So, the class will be asking me that, sir, how much area near equator should be called as equatorial region? Then my answer is that how much area near equator would have the homogeneity or identity would depend on the purpose of your study. For example, if you are studying climates of the world, then there would be one particular area near equator which has homogeneity in terms of climatic elements. But if after climates we study the agriculture crops of the world, if I am doing the subject of agriculture for the whole world, don't you think area near equator with homogeneity in terms of crops may not be exactly same as it was with climate, because crops do depend on climate, but crops also depend on market forces or government policies, etc. So I hope you understand, the moment the purpose changes, the definition of equatorial region would change. And not only equatorial region, all the 6 regions would have the same. So I want you to understand that how much would be a given area out means for all the 6 regions I'm making this statement, how much would be the particular area, that depends on your purpose. Climate would give you one definition, agriculture crops will give you some other definition. If you are doing in the 3rd lecture mineral distribution, do you think the definition would again change? Yes, please? Yes, sir. But you know, we are in a general studies class. We don't have one particular purpose. We do have purpose, but we don't have one particular purpose. We are not here to study only the climates or only the agriculture or only mineral distribution. We will be studying almost everything. So what kind of definitions we need to give for all the 6 regions? Not purpose specific, but in general. So what I am making clear is all the 6 definitions which I am going to reach in the next 10 minutes, they are in general, with the understanding that for a particular purpose the definition may change. Is okay? So we'll go for general meanings here, and with that general orientation you can understand equatorial region would mean 0 degree to 10 degrees north and south. This is general definition of equatorial region, but for a particular purpose it may be 0 to 12 degrees, north and south, maybe something different also. And since we are doing these things for the first time, so let us mark the area also so that we get familiar, because this would be the basis of every lecture of geography and ecology. Whenever you deal with the nature, you will have to use these kind of regionalization. So please mark this area 0 to 10 degrees north and south roughly. This is equatorial region of the world. Yes, is everyone okay with the first region? Now, second region which is given by the scientists in the world is tropical region. Now, what is the general definition of tropical region? By tropical region, we generally mean this area, the whole area between the two tropics. Now, when I say this is the whole area between the two tropics, it goes without being said that equatorial region becomes a subset of tropical region. Subset, you understand? Yes, please. You must understand. CSET, again, I repeat, qualifying exam, no? So, what is tropical region? 20.5 degrees north to 20.5 degrees south. And please mark the area the way I have done. So we have done 2 out of 6 regions. Now, and please do not do anything till I finalize the things, okay? I told you in my first class the rule, a student has to be one step behind the teacher. Okay, in every class you should do that. Be a student always. Now see, what if I go to this area of the earth? Please, you don't do anything, just be on the board. When I go outside the tropical region, in this area which I am marking with dots here, and same way here in the southern hemisphere, can I say that this area will also have some good amount of heat? Means just be on the board and think of what I say. In the month of June, when the sun is approaching Tropic of Cancer, then there would be a good amount of light going on the other side also. For example, if this bulb is over the Tropic of Cancer, then don't think the area beyond it is also getting almost the same good light. So scientists of the world have found that in terms of physical conditions of nature, this area has lot of resemblance to the conditions in the tropical region. But it is not exactly tropical region. And you know, when we have to say some area is similar to some other area, but not exactly, then we use a prefix sub. So this area of the world which I have marked with dots is named by the scientists as subtropical region. Means something similar to tropical, but not exactly, So write the third region, subtropical region. Now you will say, sir, how much area should be called as subtropical? My first reaction would be, it would be decided for the particular purpose. But since we are doing general definitions, then scientists suggest that you can take a wide area here from 20.5 degrees north to as much as 40 degrees north. And you can do the same in the southern hemisphere, 20.5 degrees south to 40 degrees south. And let's mark this area with dots here. So let's say this is that area. And same way you do it for southern hemisphere. Now we come to fourth region. The fourth region given by scientists is named as temperate region. And what is the general definition of temperate region? Please see here. This whole area between the Tropic of Cancer to Arctic Circle, this whole area is called temperate region. It means it again goes without being said. Subtropical region becomes a subset of temperate region. The same way in southern hemisphere. So this whole area is temperate region. So I write here the definition from 23.5 degrees north to 66.5 degrees north. And similarly in the southern hemisphere, 20.5 degrees south to 66.5 degrees south. Yes, is everyone okay with the 4 subregions? Now be on the board for some special discussion for the area left now. Now be on the board. See here. Can I say this area which is left for demarcation is an extreme area of the world? By extreme I mean it has extreme climatic conditions. This area is very cold area of the world. And can I say since this area which is left is very extreme climatically speaking, for that very reason it is less frequently visited area. Means given a choice for a world tour, would you first go there? No. You will go there only out of compulsion, or you have already seen the world, then you say let me see the extreme area also before I die. No. Means who will go there for the first time in life? Means if someone is going for the first time for a foreign tour, who would go there first? Only one who is being compelled to go there, no? Like a scientist working in India, for some project may be sent there, and he or she may be going for the first time out of India and goes to the extreme area. So mind it now. If this area of the world is extreme, and I say for that reason it is less frequently visited area, can I say anything which is less frequently visited in life is less precisely defined? Which things of life you define more precisely? The ones which are of regular use, regular contact is there. Or those who are not getting my point, which cousin you know the in and out, the remote cousin or close cousin? Close cousin, because you have been partners in crime. Remote cousin you meet after months, neither you are interested in that person nor the cousin is interested in you, no? You hardly know them. And when do you need to know them? When there is some special occasion only, right? So these are remote cousins of the world. We do not know them in specific unless until there is a clear purpose for their study. So my point is, this is the way subject deals with them. This area would have less precise definitions. Remember, here also we don't have very rigid definitions. I told you, definitions here also will change from one purpose to the other. But still, in general, we could have these values here. So this area would be defined less precisely. It means we'll leave it to the scholar that when you go there for some purpose, some particular study, then do it with a precise definition. Otherwise, we'll have broad general outlook. So keeping this background in mind, first I'll take the area called polar region. Please write the term polar region. Now you will say, sir, what is polar region? Instead of giving the proper latitudes as I've done for the other 4 areas, I'll say my subject teaches me that in general you can think of polar region as areas around the poles. Now you will say, sir, how much around the poles? I'll say, let the scholar decide it, who goes there for a particular study. Okay, that is the way we handle this. So what you do is, without writing the latitudes here, you just mark this area. Because I have already told you that there are 6 subregions. So leave some area here and mark this region as the polar region. And same way in this other hemisphere. Now we come to the last subregion. Now see, we are left with this area for nomenclature. Now be on the board. Scientists of the world find the area which is left as the sixth sub-region, which I have to write now. This area they have found has conditions of environment, climate, etc. very similar to, yes please, polar region. Remember I told you, the regionalization is based on observations. So this area is found to have conditions similar to polar region, but not exactly. So we call it as subpolar region. Now, why did I say this is all based on real observation? Because if I would not have told you that, some student will come to me and later and say, sir, this area is close to temperate region. Why can't we name it as subtemperate? But I have given the answer. Why don't we name it as subtemperate? Because conditions here are not like temperate, they are like polar region. So please write subpolar region. Now you will say, sir, how do you define subpolar region? I would say subpolar region can be understood as higher latitudes. Please see how do I do it. Higher latitudes just outside the Arctic Circle and the Antarctic Circle. Yes. Is this scheme understood? And this would be the basis for all classes wherever you deal with nature, whether it's ecology class or geography class. This is a universal scheme. But before we leave it, let's have one more discussion. Whenever anyone who deals with nature and is studying the whole earth, he or she generally would go for this scheme. But sometimes you may not need this much of detail. You might need to discuss some particular topic of interest in a broader way. And you may not need 6 regions. Then in a broader perspective, we can see the earth in 3 regions also. We can say there is tropical earth, there is temperate earth, and there is polar earth. Now in threefold regionalization, this whole area would become polar region. Or I may use other words, I may say the earth can be seen in 3 parts: lower latitudes, middle latitudes and higher latitudes. Okay. So what I do now is I write the threefold division on the side here. If you have space, you write the way I write, or you can write separately somewhere. So in a broader perspective, we go for these 3 regions. So this region would be called as, yes please, tropical region. What is the other term? Lower latitudes. And then second region is the temperate region. Or we can say middle latitudes. And third would be polar region or higher latitudes. So as per the need, you can go for detailed or you can go for broader regionalization. It's something like when you are in some journey and you meet a foreigner and you happen to have conversation and he or she asks about India, you say the Indian culture can be seen as North Indian culture and South Indian culture. But in the course of conversation, you get to know he or she is a professor of Oriental Studies in London School of Economics. Means he or she studies eastern part of the world. Do you think then immediately you need to switch your gears to more detailed understanding of India's culture? Then you will say within North India you have lots of differentiation. Within South you are different, and then you'll say Northeastern culture is to be also understood as the great part of Indian culture, means you'll go for more details there. So this is how you switch over here also, that you go for detailed regionalization or broader regionalization. Yes, is this scheme understood? When I was doing this scheme on the board, some students of the class would have been reminded of the terms they have seen in school as a torrid zone, frigid zone, etc. No? So someone may have a question that, sir, when do we use those terms, what we had seen in school, torrid, frigid, etc.? Then my answer is, the Greeks, who were the first geographers of the world, they divided the world for the first time on the basis of climatic conditions. And they divide, and you know, at the time of Greeks, knowledge about the world was very limited. When you have less knowledge about something, you can't go for a detailed regionalization. You just go for a broader approach. So Greeks divided the whole world into 3 regions on the basis of climate. Means they gave us 3 climatic regions of the world. In that context, we have the use of the term torrid and frigid, etc. But before I give you that climatic regionalization, since I am preparing you for the future classes of mine, so what I'll do is I'll have a 15 minutes or 10 minutes talk on the 2 terms today, weather and climate, and then we'll go to those terms, okay? Because remember, today's lecture is with the purpose to have the things which I need in the future classes, okay? So with this, and to tell you that how I'm going to teach you these things, so I'm going for this brief discussion of weather and climate. So write the title, Weather and Climate. And do remember, whatever comes in my discussions today, it will all understood, it would be all done again in lots of details. These are just reflections of what will come in the future classes with details. Okay? It's like more of a trailer. Picture baad mein aayegi, right? So don't misunderstand that this is what we have to cover on this topic. Okay? Now please be on the board and don't write anything. Can I say both these 2 terms pertain to the state of atmosphere? Yes, please. Means the moment someone says weather or climate, you understand that someone is talking about the state of atmosphere. Now, as already said a few minutes back, can I say, though the atmosphere gets manifested in many different ways, but the 2 major elements manifesting the state of the atmosphere would be the heat and second would be moisture. And I said these are so major elements that even a common man will tell us the same. The words may not be same. A person on the road may say heat, instead of heat, temperature. And instead of moisture, he or she may say rain or lack of rain, right? But the meaning would be these 2 only. And the same is in my class also, that everyone agrees that these are the 2 major elements representing the state of the atmosphere. Yes, please? Which we understand through weather and climate. But since we are science students, we are much better than the common man on the road. So today I add one more element here. And what I add would be the common thread of all my classes when I deal with atmosphere and world ocean. And what is that? I say weather and climate both represent the state of the atmosphere involving heat, moisture and their motions. It means one very important element for us to understand the nature would be that heat and moisture travel from one place of the world to another. And if they were not traveling, Earth would not have been a living planet. So one theme which will bind all my classes of atmosphere and world ocean would be the transfer of heat and moisture. So today I'll just give a trail of it, means I'll just mention it and we'll see the details in different chapters. Anyone who is not getting my point, what do I mean by movement, how motion and heat gets transferred? Let's take India's example. During June to September, India gets covered with a very massive system of winds from Indian Ocean, from southwest direction. And we Indians call it as southwest monsoon. And many of you would remember from school days that this southwest monsoon, which on an average lasts for 4 months from June to September, brings India 3/4 of its annual rainfall. Means India gets 3/4, 73 or 74% of its rainfall in just 4 months. And this monsoon is so important for India that without this monsoon you cannot even imagine what India would have been. I'll give you a suggestion today that after the class is over, when you are moving towards your room or on the way if you are having a cup of tea on the tea stall, while having that tea, just visualize what India would have been without monsoon. Within a few seconds, your mind will go blank and you will say, let the teacher decide. Because you cannot even think of India's existence without this monsoonal winds or the moisture what it brings for India. It is so important. Now, if I say monsoon brings moisture to India 3/4 of rainfall, so it means during June to September, when it rains somewhere in India, can I say it's clear indication that Indian Ocean moisture travels to different parts of India? Yes, please? So during June to September, almost the whole country will get, at least from the tip of the southern tip of India till the Shivaliks, whole India will get covered with monsoonal winds. So the moisture we get during summer season, June to September in Delhi, which moisture is it? Moisture of the Indian Ocean or not? So it means this example tells you that moisture moves from one area of the world to another. And if you relate it to school science with a simple concept called latent heat, then immediately you'll understand when moisture travels, heat also travels. Because you know latent heat is the heat which is either released or absorbed when there is a transition from one state to another. Let's see a trailer of it here. During summer, sun gives heat to the Indian Ocean. And what happens on this, as the sun gives heat, the surface what is it? Huh? I'm not getting it. अब नहीं है ना, वो इसको मैं ढूंढ रहा था. There's some extra students in our class, no? These, it's not there. Yeah, without fee also. Hang कर गया मेरे. अभी अपने आप ट्राई करते हैं. बुला ही लो उसको. So see, during summer, sun gives heat to the waters of the Indian Ocean. The surface water means liquid changes into vapor, the gas. And you know from school science, when liquid water becomes vapor, in this transition, latent heat is absorbed. Now this expression which I have written on the board is very simple, but very crucial for our course. Because this gives us a learning that every molecule of vapor in this air in the room or outside now is a source of energy. Because vapor is holding latent heat. Whenever this vapor will change itself into liquid droplets or into ice crystals, that is what we call as cloud formation, then it would release that latent heat. So in the coming days we'll do a chapter of condensation, cloud formation, precipitation. So when vapor changes itself into water droplets, this is called condensation. And or vapor may change itself straight away into ice crystals, solid. This is called sublimation. Gas to solid or solid to gas, we generally use these days one term. Though some student may say, sir, we have heard of the word deposition, but sublimation is more popular. So it means what is cloud up in the atmosphere? Cloud is the manifestation of condensation and or sublimation. And when this vapor goes for condensation or sublimation, latent heat is released. So this latent heat is going to do wonders in nature. Means it's very early today, but I'll just confuse you by saying that in a tropical cyclone, which is so destructive, I can say what kills you finally is the latent heat. Or what kills you in a tropical cyclone is vapor, because all atmospheric phenomena have major energy source, this vapor, through the formation of clouds, through condensation and sublimation. Means we are going to see in this course that oceans are a supplier of energy to the atmosphere. It means atmosphere and oceans will always act in conjunction with each other. And how does ocean supply energy to the atmosphere? Through vapor. Now let's leave it there. We'll do it in detail in the coming classes. But let's come to monsoon. So what is monsoon for today's lecture? Monsoon is like a machine which collects the vapor of the Indian Ocean, or I can say which collects the heat of the Indian Ocean. In what form? Latent heat. And then this moisture laden air will come to some part of India. And in our course you will see that this moisture laden air, when it comes to some part of North India or any other region, this air would be forced to rise. And as this air rises, it will get cooled. And cooling would make it reach that condensation or sublimation. And what would happen during that condensation, as already shown, somewhere in India, latent heat would be released in the atmosphere. Now this heat which is being released during the monsoon season in this part of India, was that heat given by the sun to this area or was it given to the Indian Ocean? It was given to the Indian Ocean. So I have proved that as moisture travels, even heat travels. So it means you understand that there is heat, there is moisture, these two are the major elements of our atmosphere, and what is more important for a science student along with that is that heat and moisture travel. So you are going to understand in the coming days that earth becomes what it is because of the transfer of heat and moisture. Now as an Indian, I said 3/4 of India's annual rainfall comes from Indian Ocean. But don't think in general, I can say most of the, or should I say this way, the precipitation we get on the continents, we largely owe it to the oceans of the world. Means most of the moisture which you get through precipitation in all continental areas of the world, most of that moisture comes from where? The oceans. Though some water, the moisture may come from rivers on the land, ponds, lakes, etc. But major portion comes from ocean. So it tells you that that heat and moisture are the two major elements, but they have their motions. Okay, this is going to be one common element of all my classes whenever I deal with the atmosphere and world ocean. Now, having said that, let's go back to school days. Everyone remembers that weather as a term is about the atmospheric conditions for a particular place at a particular time. So when I talk about the state of the atmosphere for a small area for a particular short duration of time, I call it as weather. But when I take the aggregation of the atmospheric conditions for a larger area and a long period of time, and you will see in my subject that as a convention, long period is taken as 30 or more years. So when I aggregate the atmospheric conditions for a large area for 30 or more years, then I call it as climate. So this is your school days knowledge. Today I have just given an important point that heat, moisture, and what is important along with that is their motion. So let's combine these two things and write one sentence for each weather and climate in the same way. So please write, the term weather refers to atmospheric conditions. The term weather refers to atmospheric conditions involving heat, moisture and their motions, involving heat, moisture and their motions, heat, moisture and their motions for a given specific area, and short duration of time. For a given specific area and short duration of time. Now let's have similar definition for climate. So please write, climate refers to the aggregation of atmospheric conditions. Climate refers to atmospheric conditions involving heat, moisture and their motions, for a larger area, and long period of time, within bracket you can write more than or equal to, yes please, how much I said? 30 years. This is just a convention or subject. Okay. Now before I go further, there is one student, Devi Priya, writing something of history. Now I would simply, since it's a geography class, I would say Devi Priya is very wrong in what she is making an observation. She is talking about Redisa and then she is talking about that how Greeks became the first geographers and all that. I am talking about the time much before Redisa, right? So please check your historical facts and then come with a better question next day. Now see here. Now, since I am trying to orient you for my future classes, I would now just add because I will go for 5 minutes some more discussion on these terms weather and climate. Now please tell me, have you understood the difference of weather and climate? Yes please. But I believe, being on the other side of the room, that I still need to make one clarification, because you may say that you have understood, but one thing many of you may not have realized is what I want to clarify. I say, though people talk about their experiences of climate, there are books on climate, there is a subject called climatology, but every one of you must understand climate is not real. The only real thing out of the two is weather. It means climate is more of a mental construct. The reality is weather, because every moment outside in nature, you experience what? The weather, the conditions of the atmosphere at a particular place at particular time. So out of the two, one, weather is real, not the climate. And those who are not getting my point, let's say I have lived in Delhi for 40 years now. Every day, whenever I was in Delhi for those 40 years, I experienced what? The weather of Delhi. Now let's say I have a friend in Paris and he wants to visit me for the first time, and he writes to me that let me know the conditions of atmosphere in Delhi so that I come prepared with. What would I do? Based on my 40 years of weather experience, I would write to him on half a page a summary shot of my 40 years experience. This summary which I write of my experience is what we call as climate. So what is real? Real is weather. Climate is just a summary shot, is a mental construct. And now what I'll do is I'll give you one more quote for the day. You all are familiar with the great person who is known for very fascinating statements on every walk of life, Mark Twain. Have you heard of this name? He's known for very fascinating statements on almost every walk of life. Now listen to me first, then be on the board. Now people are looking for their quotes now. You just be on the board. Mark Twain gave one statement on the today's lecture, and he did it better than a chapter of a book. Mark Twain said, climate is what you expect, weather is what you get. Please write this statement, and this is the way we'll study our subject. That more practical orientation would be there. So write under Mark Twain's name and see how good this statement is. Climate is what you expect, semicolon, weather is what you get. Now this to me is better than one chapter of the book on the same topic. Now there is a student Janvi writing, sir, climate changes every 6 months. How it is related with 30 years? I don't know which 6 months period, from where you have got that magic figure of 6 months, no? There's no climate change or something like that, the change of climate every 6 years or 6 months or so. Please wait for the subject to be understood then. Yes, please, is this making sense? Do you feel that it sums up the things much better? Now, basically I want to tell you that this is the way we will study our subject, more practically also. Now, whenever I mention this statement, I'm reminded of one personal experience. So I'll take few minutes. I'll be very brief. Let me share with you one experience I had with my family members. Means we had gone somewhere and I had some experience of this sort. In one of the summer vacations, I went from Delhi to Shimla by train. And you know, train journey involves number of hours. So during that train journey, I spoke a lot about Shimla to my family members. Means I got an opportunity to impress the people at home with little of geography I know. And I spoke a lot. But later I had to repent a lot. Let's see what was the issue. I spoke a lot about Shimla in that journey. But unfortunately, when we reached the railway station of Shimla, the conditions of the atmosphere outside were extremely bad. High wind speeds, heavy rains, conditions were so bad that we were not allowed to go out of the building of the railway station. In fact, we were advised by the railway staff that get your bookings cancelled and take a train back home. And we had to do that only. So from the railway station, we got all bookings cancelled and we got a ticket for return journey. And when we were waiting at the platform for the return journey, I found my wife was looking at my face. And she didn't say anything, but I could read a question on her face. As a teacher, I can read the faces, no? So question was crystal clear. She was asking me, what kind of geography teacher you are. Because she was not able to correlate what I had been telling her on the way to Shimla and what was happening outside in Shimla. Then I had to tell her without her asking me that what I told you on the way was the climate of Shimla. What you are getting outside is weather of Shimla. So that day I understood Mark Twain better than any other day. And that day, I made a new observation. I made a new statement. Now I say to my class, climate attracts you to an area and weather is something which forces you out of that area. So write a new statement and think of the subject. So please write, it is the climate that attracts people. It is a climate that attracts people. Put a comma. And the weather that makes them leave. It is the climate that attracts people. Put a comma there. And the weather that makes them leave. And the weather that makes them leave. Is okay? Now, before I go further, let me tell you that I have never been to Shimla. It was just to have your attention on the board. Okay, I keep telling lies in the class, but next time the lie would be different. Okay, I've never been to Shimla so far. Anyway, now let's come back. Now there's a student Smriti writing, sir, then summer and, now think of this statement. Smriti writes, sir, then summer and winter are climate or weather? And nothing of them. Summer and winter are seasons. Okay. So please understand, every day of, now mind this just to have a clarification, every day in your summer season in Delhi, what you experience is weather, right? But what kind of summers or what kind of winters Delhi has, that would be understood as climate. That anyone who comes from Chennai to attend our classes, many of those students have joined 7:30 batch. But let the winter come, they will repent. I hope you are getting my point. Means a student who is from Chennai or any other such coastal location south has joined the morning batch with the belief, early morning I'll be very fresh, having attended the lecture, I'll have the whole day to crack this exam in my room. Let winter comes and I'll show you the same student has jet lag without air travel. Means the students will find that the winter in Delhi is very different from winter at home. Okay. So summer and winter are seasons. But what kind of winters and summers you expect in a city like Delhi or in Amritsar or in South, they all are references to climate. Okay. Now, I knew someone would come out with this also. There is a student Arpan writing, sir, can't weather attract? Then I'll say, if weather attracts, it is the climate only. I hope you are getting the point or not. See, I said it is the climate that attracts people, and weather may make you leave. So someone has to counter my point. There's some student with this strategy, let's see. No. So for this student, I have prepared the answer. That if weather is attracting you, it means it is something what you had expected. Yes or no? So it is the climate only. So my statement is correct. Now, if this is all understood, now we go back to Greeks. Greeks divided the whole world for the first time into how many zones? 3 zones. It means they didn't have much knowledge of the world, so they had to give us a very broad kind of division. So let's see which are those 3 regions, and it's all very simple, 5 minutes of work. So let us go for the 3 zones. Please write this title. Greeks. Against that you write 3 climatic zones. And please make a circle to represent the earth again. And please draw important parallels. No need to write their names now. You just draw the important parallels. Now, let's see which are the three climatic zones identified by the Greeks. Where were Greeks in this? Can I say Greeks were here in Europe, right? Now, listen to this carefully. Greeks who lived in Europe, they found that areas which are south of them are very hot areas of the world. And they referred to this area. Remember, now I have already said they identified how many zones? 3. It means they looked at the earth in a broader perspective because knowledge was limited. So they found that areas which are south of them, means towards the equator, they are very hot areas of the world. So they referred to this tropical belt of our previous part of the lecture as torrid zone of the earth. So please mark this as torrid zone. So tropical areas of the world were called as, lower latitudes of the world were called as torrid zone under this scheme by the Greek scholars. Now let's make one rule for all future classes. See, if you look at the Earth's surface in two hemispheres, northern hemisphere and southern hemisphere, you will find broad patterns of Mother Nature are almost same. But when you go to details, they do vary. Because here in the northern hemisphere, you have a mix of land and water. And you know land and water are heated differently because specific heat is not same. Whereas 80% of the Earth's surface of southern hemisphere is water. So when we deal with the details of our topics, then they do have variations. But since we are in the beginning of the course and we are only discussing broader things, so if this is torrid zone, you need to mark the other side also as torrid zone. Now, so what is the first zone given by Greeks? Let's write that, torrid zone. And what does it mean in English? Torrid means hot. So torrid zone would mean areas with hot conditions. And which area they referred as torrid zone? As already shown, tropical region. Or from my earlier part of the lecture, I can call these areas as lower latitudes. Now see, Greeks found that areas which are north of them, they are very cold areas of the world. Means areas which are towards the pole, they are very cold areas. And they refer to this polar region of our previous top part of the lecture as frigid zone of the earth. So please mark this as frigid zone. And as per the rule, write the corresponding area in the southern hemisphere also as frigid zone. So the second area they named as frigid zone. And frigid, you know, means cold, so areas with cold conditions. And which areas they referred as frigid zone? From my first part of the lecture, polar region. Or we can call these areas as higher latitudes. Now we come to the third region. Please be on the board. Greeks were here. They thought that we live in the best part of the world. Neither very hot nor very cold. So they called their own area as a temperate zone. It means the word temperate we have already used was given by Greeks for the purpose of climatic regionalization. But today we use it in our general reference. So please write the third zone as temperate zone. Now please tell me, if torrid was hot and frigid was cold, what is the meaning you get, the first impression you get from the word temperate in English language? No, one word you give me from English language. Moderate. Yash Singh has written online and most of you said the same, moderate, no? The first thing which comes to mind from the word temperate is moderate. So please write areas with moderate conditions. And which areas they referred as temperate zone? Middle latitudes. We have already called them as middle latitudes. So say if you check your school book today after the lecture, you will find under Greek's regionalization of climate, this is what they have given. And I hope everyone finds there was nothing great in this discussion. If any student who knows the three English words, torrid, frigid and temperate, would understand this scheme. Means there was no reason for me to cover the class because there is nothing much technical here. So listen to this point now carefully. That if this was the only purpose, what is given in school book, I would not have covered this topic. Means I would have left it to you for reading of this in the NCERT book. But having given this, I want to establish a connection with something which is very important for my future classes. Means this is school days knowledge, but I'll take you to the kind of things we have to do in our classes from this discussion. And for that extra discussion, I asked my class to write this word moderate within inverted commas. School books will not do that. Now we are going beyond the school book and I'm just going to give a brief orientation for this area of the world for some future classes. Now be on the board and leave everything, like just put this word in within inverted commas and be on the board for the discussion. Now see, weather by definition would change at every place of the world. Means think of Karol Bagh. The time you woke up today, you had one set of conditions of atmosphere. When you got ready for the class, when you came here, you had another set of conditions. During our lecture, conditions are changing and by the time we leave the hall, there will be a new set of atmospheric conditions. When you go for lunch, you will have another new set. So it means we understand that atmospheric conditions, the weather conditions keep changing at every place of the world. But in the course of our classes, or later when you will travel world over, you will get to know that yes, weather changes everywhere in the world, but middle latitudes of the world, and I remember one more rule, when I focus on one area of the northern hemisphere, and I do not say anything over the southern hemisphere, please take the broader picture the same way, okay? Generally our focus will be on the northern hemisphere, but if I am not mentioning anything in the southern hemisphere, it means broad designs are same. So through my subject and through the subject of ecology and later through your travels in the world, you will get to know that this area of the world, the middle latitudes, experiences the maximum variability of weather conditions of the world. Means weather changes the most in this part of the world. Weather changes everywhere, but it changes the maximum in the middle latitudes of the world. And since I said this is all about orienting yourself to orienting students to the future classes, so let me give you some practical notion also how much variability I am talking about. I'll give you some illustrations on practical level so that you get to know that here the variability is very extreme. There's a first illustration. In Europe, there is a popular saying that when two Britishers meet, their first talk is about weather. It means unlike we Indians, they don't talk about others. You know, when we Indians meet, we talk about some common friend for criticism or some common relative and all that. But Britishers don't do that. They talk first about weather. Why? Because weather is a matter of interest to them all the time. Why? Because weather changes so much that it's a matter of interest all the time. That they first talk about weather before anything else. And whereas think of we Indians hardly talk about weather. We talk about weather when it is more extreme situation. If today there is a thunderstorm, some trees fall and there is a traffic jam and all that, then you will say, they will love to talk for a few minutes about the weather. Now let's think of the contrast that we Indians are not used to talk about weather. For example, in June, you are in Delhi and you are going for lunch with your friend. While walking to that restaurant, your friend says it's very hot today. Don't think chances are you are going to ignore this statement. Means in June in Delhi, what else would you expect? So you are going to 95% chances you are going to ignore that statement. Let's say while waiting for the food, he or she again says it's very hot. You may tolerate it one more time. You may not react. And while having lunch, he or she again says it's very hot. Then you are going to react. You will stop eating and you'll say it was hot in May, it is hot in June, and it is going to be hot in July. Let's talk something different. Weather changes in our area, but overall it seems to be as if there is a relative constancy of it. We don't love to talk like what Europeans do or what in particular Britishers do. Let's have another illustration. Please recall the movies and the TV series which come from this area of the world, North America and Europe. Have you not seen many times the actors who are involved in those, the actor might be leaving the place in the morning with a shirt or a t-shirt on the body, but he or she also carries leather jacket or something like this. The day started with a t-shirt or a shirt, but along with that, he or she keeps a leather jacket or something like that because there's a fear, I may need it. But we Indians, when we wear a shirt in the morning, we are confident in that season, so much confident that we pack our woolen clothes in big trunks, and that too for months together. And you know, when winter comes, our family members take weeks to get those clothes out, no? And some particular clothes do not see every winter, because by the time they come out, winter is over. Whereas Europeans can't have such kind of big boxes to keep their woolen clothes. They keep everything handy. When a European family goes for a picnic, in their cars they keep all kinds of protection for summer, for winter, or for sunny conditions, for snow conditions, for rains. Then only they go for picnic, otherwise no, because they never know what may happen in those picnic hours as such. It is such variability here. Third example, and this is what everyone knows. Recall the matches you have seen, the cricket matches being played in England. Have you not seen they have lots of interruptions all the time? Now, you were watching a cricket match in England, there was a sunny bright weather condition, you went out for a cup of tea, and when you came back after 15 minutes you found there's no match being played because now you get the news that it's raining there. So you switched off the TV with the belief that why should I waste my time now sitting at home. You went to a friend's house at 30 minutes distance, and you might find your friend is watching the same match again, because conditions have now again come to sunny conditions. It is so much of variability. And my last point, in the course of ecology classes and the geography classes, you'll get to know, or in your reading of NCERTs, you'll find in this particular middle latitude region, there are some pockets where you may experience the elements of 4 seasons in just 1 day's time. It means what other areas people experience in 1 year's time, you may experience in some particular pockets of this belt in just 1 day's time. It is so much of variability. So I hope you have got enough hint that this is a very extreme variability of weather conditions, and we don't see it in the other parts of the world. Now, let's leave it here and come back to our previous part of the lecture. Listen to me carefully. Let us suppose I did not teach you about this portion today. Means let us erase last 10 minutes of lecture and let's come back to the moment when I stopped, when I gave you this. Please tell me honestly, if you would have done only this much what is given in school book, would this word temperate zone or temperate give you any idea about this variability? Means let's suppose we have not done this and you are given this classification which we have done earlier from a school book. So tell me honestly, would this word temperate zone give any hint about the variability? No, number one. And second, can I say, in fact, the word temperate is taking us in a different direction. It is not giving any idea about variability, rather it's giving us a different outlook. So, scientists of the present times, they say our Greek ancestors made a mistake by using the word temperate for such an area which has so much of variability of weather conditions. So our scientists today suggest that we should avoid using the term temperate for this belt and we should simply use the term middle latitudes, because that's a value neutral term. It doesn't indicate anything, so this is good. So it means they say that word temperate is a misnomer for the middle latitudes weather conditions. It's not a correct representation. It's misleading a term. So scientists suggest that we should avoid using this term. But you will find in the course of my classes or ecology classes, or when you read any geography or ecology book, you will find though temperate is a misnomer, but it is still a very popular term. Means every book, every teacher of ecology geography will keep using the word temperate. In fact, sometimes you will find the first chapter of a book says temperate is a misnomer, we should not use it. And in the rest of the chapters, the same author will keep using the same term temperate. So one author has written, one scholar has written beautifully that we all know the term is not good, but we still keep using it. He says the only reason is that we do not want our forefathers, Greeks, getting annoyed up in heavens. Means if we don't use it, they will feel bad about it. Only that is the reason that we are using this word, otherwise it should be avoided. It means it's something like that your grandparents give you some advice and you say, yes, I'll follow what you say. No. When you came to Delhi, they have given advice about the clothes you should wear, the timings you should come back to your room. You said, yes, but you know this old person is out of place these days. No, that he doesn't go with the generation I live in. So you say out of respect, yes, I'll follow your advice. But inside, you know, I'll not do that. Okay. So write one sentence for this and then I'll take you further. Please write. The use of the term temperate, sorry, the use of the term temperate is a misnomer, for the middle latitudes, as these areas experience the maximum variability of weather conditions of the world. Maximum variability of weather conditions of the world. Okay. Now, before I go to the next section, Any question you get in the mind out of this discussion? Yes, please. One student, Tanvi, has raised a question which I expected from everyone in the class. Now see, after this discussion, the question should be what exactly one student, Tanvi Singh, is asking. Why is there such extreme variability in the temperate region? Means why do we have such variability of weather conditions in this area? Then my first answer is that this is what I'll show you in the coming classes. Means in the future classes you'll understand reasons for this variability. But since I have mentioned it today, and I also said I'm preparing you for my future classes, so what I'll do is I'll give one broad idea that what is special about this area which is the reason for variability. But the only handicap for me is that I have to do it without the technicalities which I have to cover in the coming classes. So if you are not bothered about the sequential arrangement of the things, just listen to me. In 5 minutes I'll tell you what is the reason for the highest variability here. But remember, we are doing it without the topics we have to cover in the future classes. So you just get the broad picture with me for 5 minutes on the board. Today is our third lecture, right? So towards the end of 5th or beginning of 6th, I'll be starting with my classes of atmospheric conditions. Means I'll start with atmosphere and later we'll bring oceans, and then together we'll see what is happening in nature. So when I start my air circulations topic, I will say when air moves horizontally, we call it as wind. And the rule of nature is air will always move from higher pressure to lower pressure. It means I'll say atmosphere doesn't exert uniform pressure on the earth surface. Somewhere you have higher pressure and somewhere you have lower pressure. Now you will say, sir, why do we have atmospheric pressure differences? The reason would be the earth's surface is not being heated uniformly. So if you ask me what is the primary reason for differentials in atmospheric pressure, the primary reason is that there is a differential heating of the earth surface. Why earth surface is being heated differently? One, because latitudes are different. Lower latitudes are being heated more than the higher latitudes. Even if the latitudes are same, the one area is land, the other is water. Latitudes are same, both the areas are land, but one is grassland, the other is desert. Both are deserts, but one is stony desert, the other is rocky desert. So each surface has its own heating process. So basically you will have n number of reasons for differential heating. So my course will teach you in the coming days that atmospheric pressure differences are primarily because of differential heating of the earth surface. And what is the relationship of heating and pressure of the atmosphere? Very simple. If my area is heated more than the other area, my area's air would be warm. And warm air being lighter would rise. Wherever air rises, we'll see we have less pressure. And wherever you have colder conditions, air is denser, it sinks over you, you have high pressure. So this relationship will give us that high temperature would relate to low pressure and low temperature would relate to high pressure. But when we'll study nature, we'll find nature is not so simple. We will discover in our 7th lecture that the pressure differences of the atmosphere, which are primarily decided by heat, they are further complicated by Earth's rotation. How exactly, that I can't teach you because we need some background for it. But I'll remind you of something what you did in school or college physics or geography also, that in relation to Earth's rotation, you have seen what is given as Coriolis effect. At least some of you remember this, that on those objects which are moving from one place to the other, like aeroplanes, like missiles, like air, like water in the ocean, All such objects which are moving from one location to the another, they are affected by Earth's rotation. That effect was studied by many scholars, but major contribution came from one French mathematician. So we have named it as Coriolis wave. So through some interesting discussions you will get in 7th lecture that pressure differences though are primarily decided by heat, but they are complicated by Coriolis effect or Earth's rotation. It means today you just understand pressure differences are the combined effect of heat and, yes please, Earth's rotation. Now, with this background, we will come to a picture of atmospheric pressure. Now, you don't raise further details, but we'll just come to the point so that we understand what is special about this area in very brief today. You will see in that lecture, sorry. You will see in that lecture that areas near equator have low pressure. Areas on, remember these are average values, areas near 30 degrees north would have high pressure. Areas near 60 degrees north would have low pressure again, and areas near poles will have high pressure. Similarly on the other side. Okay. Now, let us see what is special about this area, because you wanted the reason why this middle latitude region has such a variability. Now you will see this area of the world has something special for all future classes. Remember, what is wind? Which kind of movement of air is called wind? Horizontal movement of air, right? But do remember, we do show winds in this diagram, which are horizontal movements of air, but remember board is vertical. Some students will have a problem for this reason. Is the point understood? That we are going to represent horizontal movements of air on the board or your notebook, both are what? Vertical. So do have that point in mind. So let's do it with the arms on the platform so that you understand that horizontal movement. So let's say board is the polar region, and on the screen side you have tropical region or subtropical, and I am standing in the middle latitudes. Means let's say this board is polar region, you are sitting in India for your examination preparation, I am in Europe for my vacations, right? Now, what is happening here? What is the pressure of the atmosphere here? Low. Polar area has high. Subtropical areas have high. So what is happening? The air will come from the tropical area towards the low pressure. The air will come from polar region. The polar air is cold and dry. It can't hold much moisture, and the warm air is the tropical air is warm and moist. Now when these two contrasting air masses meet in the middle latitude, since they are contrasting, they don't mix into each other. Between these two contrasting air masses, there is a zone of transition, and this phenomenon was first studied by Norwegian scientists, and they studied it first when what was the time of First World War. Means they were doing this research at the time of First World War. Since it was a time of war, so they called this zone of transition as a front. Taking the analogy from the war, you know, in a battlefront, two armies may stand face to face, but they won't shake hands with each other. So, scientists in Europe named this zone of transition between the polar air mass and tropical air mass as front. So in future classes you'll see that this area of the world is very special in atmospheric science because it has a phenomenon called front. And after a few more days I'll teach you cyclones of the world. And geographically we'll say there are two types of cyclones. The one which occur in our areas are called tropical cyclones, which are very destructive. They are less frequent, but they are very destructive. And those which happen outside the tropical areas would be called as extratropical cyclones, means outside the tropical. And since they occur more in temperate areas, they can also be called as temperate cyclones. And some of you may know that temperate cyclones are very frequent, but they are not destructive in nature. So you will see the same Norwegian scientists will give us a theory, and they say that first the two contrasting air masses will make a front, and some of these fronts under favorable conditions would result into temperate cyclones, and these temperate cyclones are the major reason for making this area experience very high variability of weather. So one major reason for the variability of weather conditions seen in this area is the occurrence of frequent temperate cyclones. Remember, our cyclones are less frequent and they are destructive in nature, whereas these cyclones are very frequent and they are not in general destructive. They are the reason for changing the weather conditions, and we Indians know it for the reason also that some of these temperate cyclones travel towards our area where India meets with Afghanistan and Pakistan, and when they come to us, we call them as western disturbances. Have you heard of this term very popularly on the news, TV channel news or newspapers? So especially during winter season, you'll understand these things in the coming days, that these temperate cyclones come to our area and they bring snowfall, rain, and sometimes hail, and a very cold condition. Because of this nature they have, the frontal. Remember, as I said, these cyclones are frontal in origin. It means they carry two air masses with them, warm air mass and polar cold air mass. When two air masses will come to India, North India, warm air mass will not make us do anything. Means we are already so hot that warm air mass would not be doing anything with us. But when the polar air mass would reach North India, don't you think you will have a cold wave in North India? So a cold wave in North India, snowfall in Himachal Pradesh and Jammu and Kashmir, rain in Punjab, Haryana, Delhi, etc., which is good for Rabi crop wheat, and sometimes even hail. All these are the changes this cyclone will do for us. It means you have got the point that this area of the world is special because it has what? Fronts, and fronts make temperate cyclones, and they are the major reason for the variability, the kind of variability I have discussed. Now, before I make you write one or two sentences here, look at equatorial area. In lower latitudes also you have low pressure. It means, remember what is low pressure? Low pressure is the zone of convergence of air. But the air which converges here would not be contrasting. The air coming from both the sides would be what? Warm air. So generally we don't have fronts in our areas. Fronts are more of a feature of which area of the world? Middle latitudes. And that really makes this area very different in atmospheric science. So today, without technicalities, we have understood a special phenomenon called front. So write this on the margin because we did it without details. And remember, everything will come in lots of details later. So please write on the margin. First, what is front? Write what I write on the board. A front is a zone of transition within bracket I write generally formed in the middle latitudes between the two contrasting air masses. Now remember, air mass is a very technical term, but for the time being you understand it's a huge mass of air, right? More details will come later. Between the two contrasting air masses, put a hyphen. Which are those two contrasting air masses? The cold, dry, polar air mass and the warm, moist, tropical air mass. If this is over, now write one more sentence, one more point in the margin only. Please write. Some of these fronts under favorable conditions some of these fronts under favorable conditions result into temperate cyclones, I repeat, some of these fronts under favorable conditions result into temperate cyclones, and these cyclones form a major reason, and these temperate cyclones form a major reason for the high variability of weather conditions, form a major reason for high variability in weather conditions experienced by middle latitudes. Fine, so you got a broad idea. Now let's leave it because this will come in details. And now we move to the last subtopic of the lecture today. And again, since details would come in the future classes, so in the next 15 minutes, I'll share with you one macro feature of our Earth, and you will get that idea strengthened that there is a movement of heat and, yes please, what is important in nature? There is a movement of heat and moisture, and today you will see in the next 10 minutes time or 15 minutes time that what exactly is the broad reason for these circulations of heat and moisture. Let's see it in a very macro perspective today because details would need number of lectures. So please write a title. Global heat imbalance. So the title clearly tells you that our Earth has some heat imbalance. Means you will get that there is some reason for nature to have those motions which I said are the binding or are the common element of all my classes. Now you keep your pen down and just be on the board for 10 minutes, and when I complete the whole discussion then I'll make you write, and then you copy the diagram also. See here. We already know one term, insolation. Incoming solar radiation. Now I take you to school days, you learned something else also, and that's going to be very important for my subject. If my left hand is the Earth, having got the energy of the sun from the entire spherical surface, this Earth out radiates that energy. So having got sun's energy, the solid Earth becomes a very good radiator, and for 24 hours from the entire spherical surface it out radiates that energy. So it means there are two things. One is insolation and the second is out radiation. Broadly, in a simplified way, you can think of insolations as earthings and out radiation as the expenditure, right? That you are losing something. So through these two words, without any detail, I'll teach you what is called global heat imbalance, and that will give you one large story of our nature, that how the things are operating and why they are operating that way. And please don't copy it till I finalize, let me complete the topic in 10 minutes. See, scientists of the world have found that between approximately 35 degrees north and 35 degrees south, in this area of the world, there is there is a surplus of heat. Reason being that this area of the world has insolation much more than out radiation. It means these areas of the world are like rich families of the world. You know, rich families spend a lot, but despite those great expenditures, they always have a surplus at home. You know, rich families, the person who is earning member, the head of the family tells the family members, don't disturb my peace of mind. Go and shop, whatever you want to do, but don't disturb me. Let me work. He says, go to London or Paris for shopping, I don't mind. Because he knows that they can't spend what I earn every day. So this is like, this is the condition in the tropical areas. That insolation received is much more than the out radiation. Even these expenditures will be great, but still there is a surplus. But scientists find when you go from 35 degrees north to North Pole and similarly from 35 degrees south to South Pole, these areas of the world have deficit of heat. And same here. Now you will say, sir, why? Because these areas have out radiation more than insolation. They are losing more heat than what they receive. Now when I say this, there would be some students having a question immediately that, sir, how come an area can lose more heat than what it receives? Anyone having that question? Yes, please? Nothing wrong to have questions, say yes only. Okay, I'll ask online students because offline students is... Tell me, is this question in the mind immediately or not? That how come an area can lose more heat than what it receives? That if you have this question, my reaction would be that wait for 5 minutes, you will understand. Or what I do is, I give you a parallel analogy. Means I'll give you something from social life and then I relate it to nature. So let's leave this for a moment and see the way I use some words in particular. Tell me, am I right if I say there are mechanisms in our modern society through which we can spend more than what we earn? Yes, please? You know, there are many ways that we can spend more than what we earn today. Same way, can I also say that RBI has mechanisms, Reserve Bank of India has mechanisms for every government of the day to spend more than what they collect in revenue. Remember, throughout our planning period, revenue collection has been in general less than expenditures. But still, the governments have been promising, every government, अच्छे दिन आएंगे. Though they know that revenue collection is less than the expenditures which they have to go for. But RBI gives them the ways, the mechanisms. This is what your economics teacher will teach you. So it means you all agree that we do have mechanisms in human society whereby we can spend more than what we earn. And then I say, if we can do so, Mother Nature is far supreme. Nature is much beyond us. Nature can do it much better than us. It means I'm giving a hint that nature also has mechanisms. Where? In my subject, mechanisms in atmosphere, mechanisms in the world ocean. What mechanisms? For example, in atmosphere winds, you would have heard of trade winds, westerlies and northeasterlies in school. Cyclones, monsoons, jet streams in the upper troposphere, and many other we'll study in this course. All these circulations, and in the world ocean, for example, ocean currents you have done in school. All these are those mechanisms which will allow this to happen. Now let's leave it here and come to one more observation, then we'll combine them together. Let us suppose the nature had only this story. Let's say whatever I've done on the board, that this area receives more than what it outradiates and the other two areas outradiate more than what they receive. Let's say this is the only picture of nature. If this was the only picture of nature, can I say the lower latitudes of the world would have become ever hotter and hotter? Yes, please. As rich family becomes richer and richer. And these areas would have become ever colder. And you know, if these areas were to become very hot and these were to become always ever colder, do you think Earth would not have been a living planet? Because too hot and too cold, both are not good for life. So nature had to do something. So nature, through these mechanisms which I mentioned, the atmospheric mechanisms and oceanic mechanisms, would go for, now mind this sentence, through these mechanisms, Mother Nature, mind this sentence now, through these mechanisms, Mother Nature would attempt moderating the global heat imbalance by transferring the surplus heat from lower to higher latitudes and transferring the cold conditions from higher to lower latitude. So you will see in every major topic of my classes, when I deal with the atmosphere and world ocean, every major circulation will have one common role, common pursuit, and that is to moderate, to reduce the global heat imbalance by transferring the heat from one area to the other and transferring cold conditions from the deficit area to surplus area. Means one thing which will bind our subject will be this transfer. That's why I said motions are very important there, that heat and moisture. Now someone may say, sir, why Mother Nature goes for moderating only? Because you know, at the end of the day, even after this transfer, the lower latitudes are hot and higher latitudes are colder. So someone may say, sir, why did not Mother Nature go for making it a uniform distribution of heat? When it had to transfer, why didn't it go for a uniform distribution? Then your subject of ecology will teach you that if Earth's surface had more uniform kind of conditions, life on the Earth would have been less diverse. And when life is less diverse, the life is less resilient, means it won't be that strong. So Mother Nature has planned for great biodiversity. In small areas, nature introduced thousands of species of flora and fauna because that diversity brings resilience to the ecosystem. Means if there is an emergency, some species may die, but the others which will survive, they will have the capability to bring the system back to what it used to be after some time. You all have heard of homeostasis principle in human body or other animals, that if there is any kind of disturbance to your system, there is some process inside which will try to bring the system back. Same way, if Mother Nature is disturbed, nature has its own mechanisms to bring it back to the equilibrium. That is called homeostasis. So nature has planned for diversity to be a support, to be a hedge, means support against any emergency. And that is how nature became so strong. But we human beings are still destroying it, no? Means we are killing that biodiversity. Means what is one thing we have done to the nature? If I was to, means if I have to sum up what we have done to Mother Nature, if I was to put it in one sentence, can I say we have simplified the nature by removing diversity from the earth's surface? We have removed the forests of the world, and instead of forests we say we'll grow the trees. You can't grow a jungle, no? You can only grow some trees there. You can't create a tree in Amazon which is home to 2,000 species of flora and fauna. One tree is home to so many species. How can you create a tree on the road of that kind? So this diversity is the mainstay of the nature, and that diversity comes with this non-uniform distribution of heat. So from equator to the poles, you'll find life zones would be changing. In your ecology classes, we'll call them as biomes of the world and all that. Okay. Now coming to the last point before you write this. As per one broad estimation, scientists will tell us that out of the total heat transfer, approximately 80% of the heat transfer is done by atmospheric mechanisms because they are more in number, and about 20% of the heat transfer is done by oceanic mechanisms. Okay. So this would be the common theme of my classes. So what you do is you make this diagram under that title, and rest means then I'll make you write this diagram in words. Just make this rough sketch first. Yes, if it is over now, please write the same diagram in words. First point, between approximately 35 degrees north and 35 degrees south, between approximately 35 degrees north and 35 degrees south, put a comma there, there is a surplus of energy, there is a surplus of energy because insolation exceeds out radiation. I repeat, between approximately 35 degrees north and 35 degrees south, there is a surplus of energy because insolation exceeds out radiation. Second point, polewards means towards the poles, polewards from 35 degrees north and 35 degrees south. Now there is a student asking what is the heading of this? Global heat imbalance. I gave you that in the beginning, no? So please write polewards from 35 degrees north and 35 degrees south, put a comma there. There is a deficit of energy. There is a deficit of energy because out radiation exceeds insolation. Because out radiation exceeds insolation. Third point, theoretically, third point please, theoretically, put a comma, such an imbalance, theoretically, such an imbalance in energy distribution, theoretically such an imbalance in energy distribution could result in the lower latitudes, becoming warmer, and the higher latitudes becoming ever colder, and the higher latitudes becoming ever colder. Next point, in reality, however, energy is transferred. In reality, however, energy is transferred from areas of surplus. I repeat, in reality, however, energy is transferred from areas of surplus to areas of deficit. In the same point, right? Next sentence. There are mechanisms in Mother Nature put a comma, both in the atmosphere and the world ocean. The mechanisms in Mother Nature, both in the atmosphere and the world ocean, which attempt moderating the global heat imbalance. which attempt moderating the global heat imbalance. Sorry. Now write the next point. As per one broad estimation, put a comma, about 80% of heat transfer is through atmospheric mechanisms, or you can use the word circulations, atmospheric mechanisms. Within bracket you can write example given: winds, cyclones, etc. And about 20% of heat transfer is through oceanic mechanisms. Example given: ocean currents. So I hope you understand this will be a common element of all classes when we deal with the atmosphere and oceans. Now, we stop here. In the next two classes, we'll be doing things related to the concept of time and many other dimensions. And then after that, we'll shift to this atmosphere and oceans. So I'll take leave from online students. Stay blessed, keep enjoying the process, and same for offline students, no? Thank you very much.